Hey everybody, welcome to Skynet Java Basics tutorial number 1. Today I'll be covering primitives and prints within Java. So let's hop right into it. Right now I have VS Code open and ready to go. If you followed Vivov's VS Code tutorial, you should see yourself when you open it in a similar interface, maybe not with the file open in front of you like I have set up here, but you'll find yourself at least facing something that looks relatively like this. So assuming you have a JDK set up and assuming your system is able to run Java code, which I'm sure it is able to, what you're going to do is create a basic Java class in which we will be experimenting and messing around with things so I can show you exactly what Java is and how it works. But before we get into that, I want to just talk about what exactly a programming language is and why it's different and why it requires so much education, the reason that there's a whole IB comp sci class dedicated to it, why it's so useful in today's world. So programming language is how you tell a computer what to do. Computers are dumb but smart. They are extremely smart in the sense that they can do calculations at thousands of millions of times faster than we can ever do them in our heads. However, they're also really dumb because they need to be told exactly what to do at every single point in every single step of the way of their calculation. So if I told my computer, just physically talk to it and say, please analyze this graph and output something, it'll just stare right back at me. It's not going to do anything. But if I talk to it using a programming language, which is how we talk to computers, I can tell it to analyze that graph, which is exactly what me and Zach and Anand did last year for our robot error identifier. It took a bunch of data and spit out some graphs, and it took a lot of code and a lot of syntax to do that. So I'll get you guys on the path to making things just like that. So first things first, we are going to be coding in Java. JavaScript is something different that Vivo will teach you if you choose to do the Discord bot course, but know that we in the Skynet bots code for robots in Java, not JavaScript. So Java is, I'd say, a middle to high level programming language. And what that means is low-level programming languages are quite literally binary in machine code. They're the things that you don't necessarily learn unless you're going to the theory of computer science. You don't need to worry about those much at all right now. Medium level programming languages would be, for example, like C, where you need to sometimes allocate memory before you create a variable, etc., etc. You are modifying things a bit more specific within the computer when you're messing around with C. We're going to be learning Java, which does all the memory allocation for you, and it gives you nice errors and defined points. It tells you where the errors are in the code, so it's really a decent starting point. And if you guys have messed with Python before, which I'm sure some of you have, that is a bit even higher tier programming languages. For example, and some of you will know what this means, some of you won't. In Python, you can make arrays of many different types of variables. In Java, you simply cannot do that. So let's get into the code itself. So right now I have Visual Studio Code set up. That is my IDE of choice. And as you can see right here, this run button is what we're going to be using to run the code. If you have IntelliJ or Eclipse and you kind of know what you're doing, just know where the run button is and where to create a new class. Speaking of which, if you have not created a new class yet, please right click on a folder in this little sidebar right here, and then click new file, type in whatever name you want. I name mine Java example A, and then add a .java to the end. You physically have to type that out, otherwise it will not recognize the file as a Java file. Okay, now let's actually start coding. You can see I've kind of set up my file a little bit beforehand because this is what Java needs. This code right here is what Java needs to actually run things. So you don't necessarily need to understand it in depth right now because that is technically what Mustafa is covering in his course, exactly why I need to say the words public class Java example A. But for now, know that when you create a .java file, you will need to type in public class and then the name that you have named the file. All right? And then you add an opening bracket, and then what's nice about VS Code is that if you add an opening bracket, it'll automatically add a closing one to the end of it. So, for example, if I create an opening bracket and then I click enter, it has that second one right there. So now that you have this set up, I want you guys to type in this section right here. Now, this really confused me when I first got into Java, exactly what this is. It looks like a jumble of words right now, and in all honesty, that is how it will stay for a little bit until you really understand what each of those words or modifiers means. So for now, please copy this down because it's kind of beyond the scope of this lesson right now. All right, let's start with the first part of this lesson, which is primitives. So in Java, there are multiple primitives, which are essentially the most basic elementary form of turning machine data into visible data. So of course, as you guys know, there's something called binary, which all computers run on, and it just consists of zeros and ones. But I'm not seeing zeros and ones on my screen. I'm seeing words, characters, strings of letters. So Java lets you create certain data types that can hold certain values. And each primitive has a special use and a special place within Java. I'll go over the main ones today, and there are some more beyond this that are beyond the scope of this video that you can obviously look up if you'd like to. So here, I'm going to type out a list of some primitives. First, you have ints or integers. Second, you have Booleans. Next, you have doubles. You also with that have floats. And you have chars. And you finally have strings. Strings is a special case, which we will get to soon. All right, so I'm now going to walk you through what each one of these primitives is. And this is going to be probably the biggest section of the video, especially if you are new to Java. So definitely pay attention here. So integer, I'm sure you've heard this term in math before. It is in essence a number, a whole number, and it can be negative, 0, or positive. So no decimals here. So integer, I'll type a quick description for it. All right, negative or positive whole numbers. So what that means is if you have a variable that is an integer, it can only hold data that is either in the form of negative or positive whole numbers. Next we have Booleans. I love these. So Booleans can only hold two values. One is true and the other is false. So those are the two values that Booleans can hold. Those are great for something we'll learn later on called if checking. Next we have doubles, which form kind of like the decimal version of integers. It's like an extension of an integer. So it can hold a certain number of, and I don't remember the exact number, you can look at it if you'd like, a certain number of digits in the form of decimal. So you can have positive or negative decimals up to a certain amount. So for example, a double I could declare could be 45.666664432, something along those lines. That would be a valid double, but think back to integers, like I said a moment ago, those can only be negative or positive whole numbers. So that number I just typed in there would not be able to be put into a variable that is of type integer. Next, we'll go into float, which is basically a little bit of a compacted version of a double. Essentially, it functions the same, except it cannot hold as much information. So we can literally copy this definition over, but add this little caveat. So it's but to a lesser extent than a double. You're really only going to be using floats if you want to save on like memory and you don't want to take up that much information or like space in the system for doubles. But for what we're doing, you will not need to care about that. It's just that I want to let you guys know that for decimal representation, you have doubles, which can hold a larger amount of decimals, and floats, which can hold a lesser amount of decimals. Next, you have char, which holds, now we're going from numbers and we're getting into letters. Chars can hold any single ASCII value. So ASCII is, I forget the exact name, what ASCII necessarily means, but it is a table that has just a ton of symbols, and they could range from the alphabet to Latin, to Greek, to random things. I have no idea what they are. They look like some crazy language to me. There's a ton of them. Chars can hold those. So, for example, a char would be a, or it'd be lowercase a, or it would be 1, but in character form. Now, this is the important distinction, is that I can set 1 as a char. It is just going to be treated as almost like a letter representation of 1. Like, for example, if I write down the number 1, like on a piece of paper, I can add to it and it'll become like a mathematical representation, or I can write a sentence around it and it'll, in that context, be considered like almost like a character in the alphabet. Not really, but you get my point. And we can have like periods, this, whatever, basically anything on your keyboard. And finally, we have strings, which I said are a little bit of a special case. So strings technically aren't primitives, but they are the most widely used non-primitive object in Java, as well as the only object that, or the most commonly used non-human created object within Java. So strings hold a bunch of characters. So for example, a string would be hello. That is a string, and it consists of characters. So there you go. Those are the main types of primitives. Now, like I said, strings have some funky stuff to them. If you want to look up like strings and something called, here's some keywords that you can check out if you're really bored later today. Autoboxing, immutability. Look up those 2 words in the context of strings, and you'll find out it's really fascinating how Java takes care of strings being not a primitive, yet treated like one. Okay, now that I've gone over like the primitives, I want to teach you guys how to actually use these things, because obviously right now I just put it in comments, which is the green part. This actually isn't code at all. This is just words. So let's create an integer first off. Okay, so the general form for creating a primitive variable, okay, and Java works with variables, is to put the primitive type name of variable, and there's a space in between the two, equals value. This is common, and a semicolon at the end. This is commonly what you will see when you are creating variables. This creates the variable and also assigns it a value, which you can see on the right hand side of the equal sign. You can also simply do primitive type, which can be any one of the ones in that little text box below. And then you can have name of variable. And then you can just end that with a semicolon right there. And by the way, semicolons denote end of lines in Java. So that right there is you just basically created this variable, but it does not have a value yet. So what you need to follow that up with is going to be name of variable, and you don't actually need to put the type before it, because when you declared it in this line, you told Java that, hey, if say for example, I name my variable x, and I said int x, semicolon. What that is telling Java is, yo, every time I mention x, just know that that is referring to an integer. So now I can just say x equals value. So now let's turn this from pseudocode, which is what I just typed out, into like actual code. Let's do int x equals 5. There we go. Java says that's all right. And if it's red, that means it's wrong. If you have something underlined in red, that means you're doing something wrong, by the way. That's Java's way of like Microsoft Word spell checking you, but for syntax. So now we have int x equals 5. Why don't we try a Boolean? So if you remember, Booleans can only hold true or false values. So I can say Boolean is true, and then I can just set Boolean is true equal to true. Boom, and it is not underlined in red, which means it's all fine. Let's create a double. Double test double equals 33.3396, semicolon. Boom, we're all fine. And I can do a float with the exact same value, so I will copy this And for those of you that are paying attention, you can see that I'm not allowed to actually name things the same. I cannot name two doubles named test double, or in fact a different type of variable with the same name. Because then if I type in like x and I have it set to both a double and an integer, Java won't know whether it should accept the double value or an integer value. So I have to name this test float instead. And FYI, for floats, they're kind of unique because Java automatically assumes all decimals are doubles. You want to add f to the end of it, f to the end of the number, and it'll automatically turn that into a float. And let's go to char test char equals, and then you denote characters by putting these single quotes right here. And I can put a, boom, there's a character. And finally, string x equals. So there are examples of how to create every single type, or well, not every single type, the types that we care about, the primitives that we care about. So now I want you guys to just maybe pause the video and practice creating a couple more, mess around with it, see when you get little red squigglies, and check out what those problems are. Of course, if you have any questions while watching this video, feel free to just make sure you finish it first, but then type in questions into the software chat. So when you guys are done with that, you can continue the video. All right. So now that I have talked about creating primitives, I want to talk about something that you might not use very often as you continue in like your programming careers and like learning, but it is still useful nonetheless. And that is going to be called casting. So casting is when you take a certain type and turn it into another type. And there are certain types that you can cast and certain types that you cannot cast into each other. So let's first start off with the easiest example I can think of is integer to double. So they're both numerical representations, so it makes sense that I can turn an integer into a double and a double into an integer if I ever want to. So I'm going to create a double. So I'm going to create an integer. Int a equals, and then I'm going to give it like a decimal value. Now that will give me an error. It says cannot convert from double to int. But I can if I take my parentheses and type in the type that I want, int, put that right before that. It'll say, okay, I will turn this 4.333 into an integer for you and then store it into int. This is useful if you are tossing data between a bunch of variables and some of them need to be in double form and some of them need to be in integer form. You can just cast them back and forth whenever you want. I will say though, be careful when you do this because you get something called loss of data or accuracy when you do cast it, because integers, like I said, they can only be represented through whole numbers. So if I cast a decimal to an integer, what do I get? Well, I get the floored, which means you just truncate the decimals. I get that whole number. So if I was to print out the variable a, it would just print out 4. No 4.33, that's like completely gone. And we could go backwards. If I was to type in double b equals, and I go double, because I want to convert an integer into a double, 6. Now you don't necessarily need to do this because Java is at least a little bit smart, and it notices that if you don't have a decimal in front of the double, a decimal in the value that you're assigned to the double, it just adds a 0.0 to the end of it. That's pretty nice. But just for clarity's sake, you can do this because this 6 is an integer, but I'm turning it into double. The last one that is kind of interesting actually is you can convert characters into integers and vice versa. How that works is there is this thing called the Ascii table. It's pretty universally recognized, and for each character on your keyboard in that Latin or Greek alphabet, whatever I was talking about earlier, there is a numerical value assigned to it. So if I say char test equals, I'm going to cast it. I'm going to cast this integer, 97. Now, if my memory serves me correctly, the value of 97 on the ASCII table corresponds to lowercase a. So what that means is I can have numerical representations of letter data. And this can be helpful if you have like niche scenarios, but then again, this is just something cool I'm showing you guys, that you can convert numbers into characters using this thing called the ASCII table. So I'd just look that up whenever you have time. It's pretty interesting. There's just like a bunch of like Greek symbols and things on there, and they all have number values. So actually, why don't you guys do this right now? Look up the ASCII table and find a character that like intrigues you, or like just like the capital A, for example. And I want you to do char, whatever name you want it to be, and then cast that number that is assigned to that letter into a character by simply putting char in parentheses. So do that, and when you're done creating that variable, we can come back here. Okay, awesome. So I hope you guys have created the variable by now. So now we're going to get into the second part of this lesson, which is printing. And this is usually where people start, but I feel like you guys should have a pretty solid grasp on what you're printing before you actually print it. So in Java, there's this, or I guess most IDEs, there's a console, which is where if I type in these magic words, system.out.println, whatever I put in those brackets will be printed to the console. That's simple. And I can really put just about anything in there. So why don't we, for example, type those magic words right into the main method, which is declared by this, and then plug in your variable. So you created a variable called, I called it test in my case. I created a variable called test. I want to print out test, whatever its value is. So inside those parentheses, I will type in test. And you can see Java likes to be fancy and start auto-completing for you. It gives you everything with T, E, S, and T in it, but the very first thing is what we care about, which is test. So now, if you give me a moment, I'm going to run this. Hold on one second. Okay, so I'm back. I had some problems with my string for some reason. It was giving me some compiler error, so I will check that out later. But let's get back into this. So now I have system.out.println.test, right? So I'm going to run that, and like if my memory serves me correctly, test, when I cast 97 to a character, test will be set equal to a, lowercase a. There we go. You can ignore all that blue stuff, but as you guys can see right here, I just printed out of the console the letter A. So now, inside these parentheses, I can put whatever I want. I made a bunch of variables up there, so why don't we try these out? I want to print out x. Boom, I get print out the value of 5, because x equals 5. And now I want to print out is true. I'm going to run that. We get a true. And then I am going to, why don't we try out test double. We should see there we go, and so on and so forth. You can print out whatever you'd like. And say I want to print out, like, I want to print out just a plain number, and I don't necessarily want to assign it to a variable because I just want to print it out. I can just type in the number 5 there, and it will print out to me the number 5. And say I want to print out a character. I can just denote a character and print A, just like that. Let me see if my string problem is fixed by putting out a string into here. Test. All right, we're good. So yeah, and now I can print out a string called test. So now I'm sure you guys have heard of this before, but what I want you now to do is type in system.out.println, and then inside the quotation marks, which denotes a string, I want you to type hello world. Awesome. So there we go. You just printed out hello world to the console, which is the first thing you'll do in many programming lessons. So that is most of the lesson for today. I will give you a small extension right now, and that is actually into string concatenations, which I'll teach you guys this and then wrap up the lesson. So say you want to print out both a string that you create for the purposes of simply printing out and a variable that you change at some point in your program. Then what you want to do is type in hello world, and then you can quite literally add something onto it, plus, let's do x. So now what this will do is quite literally just take hello world and take the value of x and slam them together. Not genuine mathematical addition, but something called concatenation, which is literally just take one thing, take another thing, mash them together. So if I run this program, I will get hello world 5. There we go. No spaces in between, by the way. It doesn't automatically create a space. If you want a space, you got to add it yourself. And you can do funky stuff with this. For example, say I wanted to do hello world space 5 and then print out something else like the backwards version of hello world. So like DLORWOLLEH. Now if I run that, there we go. See, I have this as a string, I have this as a string, and I sandwiched x in the middle of it, and x equals 5, which is why the value 5 was printed out. So that just wraps up about everything for today. I hope you guys enjoyed this lesson, by the way. Tell me if I should change the way I teach, if you guys would like to see something else within the lesson. Of course, please ask any questions about this stuff. It's genuine. This in itself is relatively simple, and there's not much you can go wrong with it unless you have like a problem within your IDE. So if that pops up and you're typing in the exact same words I am, and you're not getting and you're getting a red line, then please contact me, Viviv, or Mustafa, or Zach, and we will help you guys get that sorted out. And until next meeting, please just mess around with Java. Like I genuinely am a believer in the fact that experimentation and just self-exploration is the best way to learn. So mess around with things, try to get ahead, learn whatever you can, and have fun with it. All right, see you guys later.